It's homework time. Yes, let's do it, yo. All right, start by putting our names down at the top of the paper. All right, my name. Whoops. There we go. Ha! All right, my name, you write yours. All right. And write today's date. All right, today, you write the actual date, where and when you are in the world. I actually love it when things go wrong like that because, you know, I just love proving that, hey, everybody messes up and there's nothing wrong with that. It's part of being human. Use redraw right to solve the following problems. Let's do it. Sandy took the train to New York City. The trip took 3 hours. Jackie took the bus, which took twice as long. How many minutes did Jackie's trip take? So a couple things we have to look there. How many minutes is what we're looking for because we're told 3 hours. But our question is how many minutes, and we're just looking at Jackie's trip. Not like the two of them together, the difference between them or anything like that. So let's draw a beautiful little tape diagram. And we need to draw 2 tapes, not just because we have 2 people, but because we have a comparative question here. We're saying Jackie's twice as long. You know, so we're comparing, so it helps to have 2 separate tapes. All right, so this here will be Sandy, and we know that this is a 3 hours. And they usually use brackets, but hey, whatever. And now we know that this is going to be, oh, well, you know, I probably should have made my 3 hours a little shorter because it's taking up too much space. But in any case, so here's a Jackie. Jackie took the bus, which took twice as long. No, I guess, you know, it's only twice as long. Okay, so there's going to be 2 times 3 hours, which I'm not going to pretend is difficult for us to figure out. Okay, obviously that's 6 hours. And the question is just how many minutes did Jackie's trip take? So we have 6 hours, right? What do we do there? Yeah, for minutes, there are 60 minutes in an hour. So if we do 6 times 60, that will give us the number of minutes. And remember, we can break this down into 6 times 6 times 10. 6 times 6 we know is, right, 36. And then we're going to multiply that by 10, ride that times 10 slide. Remember that from way back in modules 1 and 2. So 360. And so Jackie's trip. Sorry, handwriting's a little messy there. I'll work on that. Took 360 minutes. That's all we have to do there. Let's go take a look at number 2. Correct. Yeah. I tell you, a cup of tea is a beautiful thing. Right now, you know, it's a cold, dark, rainy morning here in Savannah, Georgia, but joy is still to be found. It's a metaphor for life. I hope you figure it out. Colton, he has a puppy, and he weighed, crazy mark, 3 pounds, 8 ounces at birth. The vet weighed the puppy again at 6 months, and the puppy weighed 7 pounds. Okay, so how many ounces did the puppy gain? So important things we're looking at here, we're looking at ounces. Our answer should be expressed in terms of ounces. And we're looking at the gain, so we're looking at the difference between them. Again, this is comparative, so it'd be good to draw 2. So we're going to have one for birth, and we're going to have one, I'll put S for at 6 months, okay? So at birth, we have 3 pounds, 8 ounces. And then at 6 months, we're talking about 7 pounds. And what we're trying to find here is the gain. So it's the difference between them. And I tell you, this is most often what 4th graders tend to kind of just skip over, is drawing this bracket of what are we trying to find. Yet it's the most important part because it shows you actually what operation to perform, how to solve this bad boy, how to work this puppy. All right, so we're going to call this G for gain, right there. And so we know if we take the 7 pounds, we're trying to find the difference between them, right? And so G will be the 7 pounds minus the 3 pounds 8 ounces. Well, now, here, I'll write it out. I'll even stick in a little LB there, 3 pounds 8 ounces. But now we know if we have to do something here to make this subtraction work, right? Because we could do 7 pounds minus 3 pounds, but then we have this 8 ounces to deal with here. And since we're giving our answer entirely in ounces, and there are several ways we could solve this, I think I'd like to convert the whole thing to just straight ounces, subtract and be done, because that's the form we want for our answer. So 7 pounds, how many ounces is that? Well, there are 16 ounces in a pound, so we can just do 16 times 7. And there are various ways we could do this, but let's just do some straight up multiplication, y'all. So 7 times 6 is 42. 7 times 1 is 7, plus 4 is 11s, so 112 ounces. And then that's the 7 pounds. And so now the 3 pounds 8 ounces, so we can take the 16 ounce conversion there and multiply it by 3 to see how many ounces are in the 3 pounds. And of course, we won't forget to add in those 8 ounces. In fact, I'm going to write that down right now so I don't forget to do that. All right, that's better. Okay, so 3 times 6 is 18. 3 times 1 is 3, plus 1 is 4, plus those 8 ounces, there they are, is, 56 ounces. So this is 56 ounces altogether. So now we can actually subtract. We can do 112 minus 56. Okay, again, there's a couple ways we could do this, and maybe you're actually even noticing something, but we'll go into that later perhaps, or not at all. But let's just do, as we did with the multiplication, let's just do some straight up subtraction with all the regrouping that it entails. So we can't take 6 from 2. So we go next door to that 1. We're going to regroup that 10, leaving 0 tens. Bring the 10 over to the 1's place with the 2 already there. So 12 minus 6 is 6. And there's 2 ways to look at this. We could do this as 10. You see the 10 there? Minus 5. Or we could take the time and regroup. Say this is 0, hundreds. And we'll bring the 100 over here as 10 tens. So now 10 tens minus 5 tens leaves 5 tens. And now do you see what I was referring to? Yeah, 3 pounds 8 ounces, that's actually precisely half of 7 pounds. And so that's why the amount that he weighed has just been doubled. So the difference is that amount. And so that gives us 56 ounces is what he gained. So the puppy, hey pupster, ooh, good boy. The puppy gained 56. Ooh, that's not a 6. Going crazy. 56 ounces. And I know I explained this before, but just to note it briefly here, that the LB is from the abbreviation from the Latin root libra, which means weight or measure. And the OZ for ounce comes from the Italian word, which derives from Latin, but it's a later form there. The Italian word onza, which literally means just ounce. So that's why we use OZ for ounce and LB for pound, which is weird. And as far as the LBS, that's a style issue. So you can, when you have pounds, like here I have 7 pounds and 3 pounds, but I still write LB. You can use LB or you can use LBS. It's just whatever you prefer. All right, so let's go on to number 3. Jessie. Female. I had to take a moment and read through here. Female Jessie. She bought a 2-liter bottle of juice. Okay. Her sister. Keeping a close eye on sister. She drank 650 milliliters. How many milliliters were left in the bottle? So again, we're looking to express our answer in milliliters. So again, it's going to make sense to do as we did before and convert this 2 liters to milliliters to perform the operation. But of course, first we will draw our tape diagram. And notice that here there is no comparison. We're not saying that her sister has twice as much or this much less or this much more. It's she drank that much of it. So we can here just draw a single tape. And this is the 2-liter bottle of juice. Move it down a little. Okay. And the whole thing is, oh, nice bracket, is 2 liters. Her sister drank, and I don't know exactly where to draw this line, right? Because I haven't done the math yet, but so I'm just going to put it somewhere. Her sister drank 650 milliliters. Remember, milliliters has a capital L for liters. And so this is what we're trying to find here. We'll call it B for what's left in the bottle. Okay, so now to do this math, we have to look at 2 liters and put it in terms of milliliters so we can actually subtract to find the unknown part. This goes way back when we were doing subtraction at the beginning of the year, when you have the whole, a known part, and an unknown part, right? We're looking at subtraction here. So there are 1,000 milliliters in 1 liter. And so let me actually write that out. So 1 liter is 1,000 milliliters. So 2 liters, what we have here is, yeah, is it easier to see there when you write it out? Is 2,000 milliliters. So this is 2,000 milliliters. Now we can subtract to find the difference quite easily, right? So we're going to say the 2,000 milliliters minus the 650 milliliters. Now there are a couple ways of doing this. I would add up. In fact, you can basically just kind of look at this at a certain point and say, oh, the answer is, without doing a subtraction or regrouping. And so let me show you how to do that. So to get from 650, I'm going to add up to 2,000. Well, I can add, I'll do it like this. I can add 50 to get to 700, right? And then 300 more will get me to 1,000. And then 1,000 more will get me to 2,000. And it's easy to put these together. I mean, technically I'm adding, but really I'm just kind of crunching numbers here. 1350. This is what I should get. Now I can do this and accept as an answer. I could use it as a check on my subtraction. 0 minus 0 is 0. Okay, now I have to regroup, and you see why adding up is a good strategy. All right, so this will be 1, this will be 10, but I'll regroup from it, leaving 9, and this will be 10. Don't need to regroup from it. Common mistake is to just go automatically to 9 there. 10 minus 5 is 5. 9 minus 6 is 3. 1 minus nothing is 1. Good. I got the same thing twice. So, there were 1,350 milliliters left in the bottle. How nice for both Jessie and her sister. Let's go look at numbers 4 and 5. These questions crack me up sometimes. So in this one, Hudson has a chain. I don't know why, but he does. And is 1 yard in length. Maya, she's got a chain too. And her chain is 3 times as long. Look out, Hudson. So how many feet of chain do they have in all? So we're putting them together here, but still we have a comparison, right? It's 3 times as long. So although, we could draw this different ways, we're going to do Hudson and Mary, and we're going to draw separate ones. And we know that Maya's needs to be 3 times as long, so we won't draw Hudson's too long because Maya's needs to be so much longer. So hers is going to be 3 times as long. Yay bouts, how's that? Okay, so this is 1 yard. And look, hey, we know how many feet that is, don't we? That's 3 feet. And the reason I'm doing that is because I should have underlined it before, but here we go. That our answer, we're being asked how many feet of chain do they have in all. And now hers is okay. So hers is going to be 3 feet, 3 feet, 3 feet. So hers is a total of, and I'll have to put the bracket underneath just for space considerations. Hers is a total of 9 feet. And what we're trying to find here is bracket. This is C for chain. We're trying to find that total amount of chain they have in all. Yeah, how's that? So it's just 3 feet plus 9 feet is 12 feet. I know this one's pretty, I'm like thinking, did I do something wrong? Because it was so straightforward there. All right, so they have 12 feet of chain in all. What they're going to do with it, I don't know. And this next one is even funnier because it's again one of those questions where there are no human beings. There are just like items at certain prices or boxes of certain weights. Nobody's connected with them. They just exist in the temporal world. Tea time. Cool, let's do it. Box weighs 8 ounces. A shipment of boxes weighs 7 pounds. How many boxes are in the shipment? And what's not stated here, but what is implicit, assumed, is that each box weighs the same amount. Now, there's a couple of ways we could look at this. We did this earlier with 7 pounds, in fact. So I think one way of looking at this is to convert the 7 pounds to ounces, and then we can compare. I'm actually going to do it both ways really quickly. Don't worry. Don't leave me comments saying it took too long. I want you to understand this. Different ways of looking at it. We do need to draw, but so basically what we have here, we're drawing one tape because we're not really comparing here. We have the total shipment, right? And this weighs 7 pounds. And now, how many boxes are in here? Well, we're not sure. So each one, though, is 8 ounces. And we did ones like this before where we just put ... these ellipses here, meaning, and then some. We don't know exactly how many. I can't draw all the lines in here to represent how many boxes are in there. But watch this. Here's the way I prefer to do this, is to note that 8 ounces and 8 ounces, well, gosh, that's 16 ounces, isn't it? And 16 ounces equals 1 pound. Okay, so every 2 boxes is a pound. And so you could work this out spatially and actually draw it out, or even just draw it out in your mind, or you could work it out mathematically and say, hey, so for each pound, there are 2 boxes. Therefore, there would be 7 times 2 is 14 boxes. And so our statement would simply be, there are 14 boxes in the shipment. The other way to do it is to do 7 times 16, which we did before, is 112 ounces, and then divide that by the 8 ounces of each box. And this will be real quick, so don't whine on me. How many 8s in 11? There's 1, because 1 times 8 is 8. Subtract and you get 3. Remember division? We now have the 2 to divide with. How many 8s in 32? There are 4, because 4 times 8 is 32. We subtract and get 0, and we're done with no remainder. And see, we get the same 14 there. So that's the alternate way of doing it. I'm sure you can come up with some other ones. But hey, guess what? Yeah, one more to do. Let's go bang out number 6 and move on from this homework time. Well, for all you cityfied folk, what is a rain barrel? Well, it's a barrel that you fill with rain. And the purpose of doing this is that you would then use this rainwater as kind of a free water supply to do things like water the plants in your garden and so on. So you're not using household water, which you have to pay for, and also is purified for drinking purposes, which is kind of unnecessary when it comes to watering plants. So rain barrels are a beautiful thing. And Tracy has one. Hers has a capacity of 27 quarts of water. Okay, now this I could tell just by looking at this bad boy from 10 feet away that this is probably going to be a little more complicated. Also, it's the last example. So let's underline 27 quarts. I don't like that underline. Let me try that again. 27 quarts. Okay, that's Tracy. So I'm going to put a little T above that so remember that's Tracy. Beth's rain barrel has a capacity of twice the amount of water, so twice for Beth. So Beth is 2 times Tracy's. Now we got Trevor. He has a rain barrel that is 9 quarts of water less. 9 quarts of water less than Beth's. So to find Trevor, and I'll use R to indicate Trevor here, because I already used T. So his is going to be, if you take Beth's and do what? His is less, right? So if we subtract 9 quarts from Beth's capacity, then we would have Trevor's, okay? And notice then, to find the capacity of Trevor's rain barrel, that's all we need to do. We'll go ahead and draw, but it's really not necessary for this first one, but we'll suppose need it for the next one. So we're going to start off. We have Tracy, we have Beth, and we have Trevor, which we're using an R for here because T's already taken. So Tracy is 27. Beth is twice that, so I'll make hers twice as long. And then we have Trevor, right, who is a little bit less. Oh, I'm sorry. I did I do that wrong? I did. No. I just put the wrong labels here, sorry. I really have no problem with making mistakes because it proves that I'm a human and not a robot. So, oh no, I did have that right. Yeah, actually I did. Yeah, so Tracy, and then there's Beth. Okay, all right, I did have it right, see? I make mistakes about making mistakes. So Trevor is 9 quarters less than Beth, 9 quarts. Glah! I'm awake. So he's 9 quarts less. I don't know really where to draw that, right? Because we haven't done the math yet, but I know it's going to be a little bit less than Beth. So we just kind of estimate the sizes of these. So Tracy is going to be 27 quarts. Beth is going to be 2 times as much as that. And let's go ahead and do that math, because that will help us with Trevor's, right? So what is 2 times 27? Well, a couple ways I could do this. I could just multiply 2 times 27. I could do 2 times 25 and then 2 times 2. Right? 2 times 25 is something I know, that's 50. And 2 times 2 is 4, so 54. And if you do it out the other way, you'll know that indeed it is 54. And now Trevor is 9 quarts less than Beth, so he's going to be the 54 minus 9. Well, so like minus 10 would be 44, right? So minus 9 is 45. See that? All right. So he's 45 quarts. And guess what? I just answered question A. So Trevor's rain barrel has a capacity, being a good boy and writing a whole sentence here, of 45 quarts. Good, and everything's in quarts so far. Isn't that nice? Nothing other than quarts. But now, of course, when we get to part B, that changes. So if Tracy, Beth, and Trevor's rain barrels were filled to capacity, and they poured all the water into a 30-gallon bucket, would there be enough room? And then explain. So what we're doing for B, for part B, is that we need to combine these and then compare that total to 30 gallons. Okay, so let's do exactly that. Let's go ahead and combine those. So we have, I'll write them in descending order to add here. And we'll do it as column addition. 54, 45, 27. We're going to combine them all. We're pouring them all into a 30-gallon bucket. So 4 and 5 make 9. 9 and 7 are 16. I can see I can make 10 here, right? 1 and 4 are 5, and 5 more are 10. Plus 2 is 12, so we have 126 quarts altogether. But 30 gallons, what's up with that? Well, how many quarts are there in a gallon? Very good, there are 4. So 1 gallon is 4 quarts. So that means that 30 gallons would be 30 times 4, which is 120 quarts. You see that? 3 times 4 is 12, times 10 is 120. So they have, and we can be very explicit here. We could say 126 quarts is greater than the 120 quarts, also known as 30 gallons, right? I'll write that underneath. So remember that that is the 30 gallons. So what they have is a little bit more. They have, and this is our fulfilling the explanation, they have 6 quarts more than the 30-gallon bucket can hold. Okay, so they have more than the bucket can hold. Woo, yeah, doggies, we done it. Nice job. Gone and finished another homework time, so I will check you again next time it is, once again, homework time.